Bismillah ar-Rahman ar-Rahim. We are resuming our talks. I hope you are enough fresh for listening to presentation of our first speaker in this section 1. In second session, Professor Madam Nina Kobisheva, Velikov Main from Velikov Main Geophysical Observatory, Rus Hydromet, from Russian Federation, on title of Climate Change Adaptation Strategies in the Technical Sphere. Madam, please.
Thank you.
Now, please.
Да, слышно. Уважаемый господин председатель, уважаемые коллеги, на доклад отводится не слишком много времени, поэтому кое-что будет докладываться конспективно, но потом это можно обсудить за кофе-брейком, если понадобится. Всем совершенно ясна цель, стратегия адаптации, но все-таки для порядка она тут отмечена. Для того, чтобы ее реализовать, необходимо выполнить следующие основные задачи. Первая задача – это разработка это значит разработка. Придется посмотреть. Значит, определение и оценки рисков. Рисков, создаваемых опасными метеорологическими явлениями, в основном экстремумами, в общем, в связи с изменением климата. Следующая задача. Ой, я тут переключила. А нет, почему? Это удобно.
Show up down.
Нормально? На кнопочку Enter нажимайте еще.
Ну, хорошо. Ладно. Значит, это первая задача – риск-менеджмент. Вторая задача – это определение и выбор основных стратегий адаптации. Третья задача – это экономическая оценка адаптации. Последняя задача не менее важна, чем две первые задачи. Следует отметить, что технические системы имеют применительно к адаптации свои особенности. И одна из них – это большой адаптационный потенциал. Вот не очень хочется соглашаться с некоторыми авторами, которые утверждают, что технические системы лишь чувствительны к изменениям климата, но не уязвимы, а уязвимы только в отдельных случаях. Мне представляется, что речь идет о южных странах. А если говорить о умеренных широтах и северных широтах, то здесь, безусловно, уязвимость технических систем очень велика. Ну, достаточно вспомнить, например, таяние вечной мерзлоты, очень большая возросшая способность к гололедообразованию и так далее. И целый ряд других факторов, которые очень сильно влияют именно на технические системы. Прежде чем говорить об уязвимости, следует отметить, что очень важно оценить воздействие на технические системы. Воздействие на технические системы происходит в связи с тем, что изменяется климат. И поэтому технические системы, элементы технической системы становятся восприимчивы к этим воздействиям и становятся уязвимыми. В результате возникает риск бедствий, катастроф, разрушений, гибели людей.
Следующий, да? Говорите
Да.
мне, я буду говорить.
Значит, вот это основные этапы, значит, воздействие, затем дальше значит, изменчивость, это затем возникает риск, и риск требует адаптации. Когда мы хотим оценить воздействие, то прежде всего необходимо пользоваться данными мониторирования, то есть посмотреть на тренды наблюдаемые и на тренды прогнозируемые. Тренды глобальные и тренды региональные. Глобальные тренды в основном экстремов, региональные опасных явлений и негативных явлений. В том случае, когда эти два вида трендов входят в некоторое противоречие, противофазу, в этом случае нам представляется важным ориентироваться на глобальные тренды, потому что региональные тренды всегда обладают большими неопределенностями, чем глобальные. Необходимо также рассмотреть и тренд уязвимости, потому что тренд уязвимости и подверженности опасным явлениям также бывает в целом ряде стран очень значительным. Это, например, увеличение, скажем, числа объектов, которые отслужили свой срок, это увеличение нарушений технологий и вот такого рода факторы. Не туда. Не туда. Так, еще. Определимся с понятием риск, так как нам сейчас придется говорить много о риске, определимся все-таки с понятием, что такое риск. Риск рассматривается обычно как произведение повторяемости некой угрозы, угрожающего фактора, или можно даже говорить о разрушающем факторе, затем умноженный на вероятность уязвимости. Что касается первой части, исследования угрожающего фактора, то здесь проводятся большие климатические исследования, и тут получено много интересных результатов. Риск, кстати говоря, в этом случае, в том, о котором мы сейчас сказали, получается либо в долях единицы, либо в процентах. Если мы умножаем ту же самую повторяемость опасного явления или угрозы на фактический ущерб, на уязвимость, выраженную в виде ущерба, то в этом случае возникает экономический риск, и он уже выражается в стоимостных единицах, в рублях или там, в долларах. Так вот, первая часть, что касается воздействия, она достаточно хорошо изучена. Ну вот здесь, например, тренд, который уже демонстрировался, опасных явлений погоды. Есть карты, это повторяемость опасных явлений погоды, и с периодом повторения 100 лет. Это карта преобладающих явлений, преобладающих опасных явлений. Вот эти карты, они позволяют выделить зоны наиболее угрожающие. Ну, зимой это, естественно, северное побережье в основном, особенно западная его часть, северная часть восточного побережья, ну и отдельные вкрапления есть и в умеренных широтах. Связано это в основном с сильными ветрами и метелями. Но вторая часть риска, вот мы говорили о двух составляющих риска, вторая составляющая риска – это уязвимость. Вот она, к сожалению, изучена не так хорошо. И дело в том, что уязвимость обычно, ее проявление, ущерб, не всегда бывает известен. Часто его либо скрывают, либо его искажают. И поэтому опираться на него можно не всегда. И поэтому наряду с прямыми методами расчета уязвимости используются и методы косвенные. Если все же есть данные непосредственно об ущербах, о катастрофах, о гибели людей, в этом случае следует рекомендовать для расчета уязвимости некий метод, который называется ДИМАК. Шкала – это шкала размера бедствий. Этот метод разработан академиком Кличко, но он используется в Соединенных Штатах, он в некоторых странах европейских тоже используется. Тут, видите, вычисляются такие показатели, как величина или магнитуда бедствия, затем социальные, экономические показатели социального и экономического риска, затем это показатель устойчивости к бедствию. Вот такие характеристики для оценки уязвимости используются. Наряду с прямыми методами расчета уязвимости существуют и косвенные методы. Вот это распространенный довольно метод оценки косвенной ущербов, уязвимости, метод, который разработан рядом авторов и зарубежных, и русских, фамилии тут указаны. Его можно назвать индексом экстремальности. Состоит он из суммы от относительных экстремумов, двух температурных максимума и минимума, осадков и ветра. Этот индекс очень удобен для выделения зон повышенной уязвимости, для выделения сезонов повышенной уязвимости, но неудобен для секторальной оценки уязвимости и для оценки уязвимости от отдельных опасных явлений. Поэтому для, так сказать, заполнения вот этой бреши разработан нами другой метод еще оценки уязвимости. Вот здесь есть формула, и в эту формулу входит средний размер опасного явления, время, в которое это опасное явление находится на данной территории, число людей, попадающих сюда, но самое главное, сюда входит коэффициент агрессивности явления. Он может быть разным, вот тут видно на графике, какой он может быть, рассчитывается по отношению к ветру, к коэффициенту ветра, потому что есть явления, которые очень большой приносят ущерб, а есть явления, скажем, дождь – это не такой большой ущерб, поэтому на агрессивность нужно обязательно умножать. Вот это еще один метод уязвимости. Сама по себе величина риска рассчитывается вот эмпирически. Мы предлагаем такой способ рассчитывать эмпирически. Это, в общем, наш способ достаточно простой. То есть здесь вот входит вот эта уязвимость, о которой только что шла речь, и вероятность опасного явления. Но вот введен для того, чтобы получить экономический риск, введен еще некий коэффициент А, это цена риска, а это коэффициент, который является долей ВВП, приходящейся на одного человека вот в данном районе. После того приводятся примеры риска. Это, вот, например, экономический риск от смерчей. Это риск, экономический риск. А вот здесь это довольно оригинальная карта. Это риск, вот здесь он выражен в процентах, это просто риск от грозовых разрядов в землю. Эта карта редкая, потому что грозовые разряды очень редко измеряются. Сотрудники ГГО просто сами по своей инициативе вот провели целый ряд измерений, в результате чего была построена эта карта. После того, как риск рассчитан, необходимо переходить к его управлению риском. И прежде всего нужно оценить, насколько приемлем полученный риск. Вот здесь есть диаграмма, она на основе шкалы ДИМАК, которую построил академик Кличко. И здесь, видите, три области. Зеленая область – это ущерб, это пренебрежимый риск. Красное – это наоборот, это чрезмерный риск, а вот желтое – это допустимый риск. Если риск попадает в область красную, это значит, что необходимо проводить адаптацию при любых условиях, каким бы дорогим это мероприятие ни являлось. Если попадает в область пренебрежимого риска, наоборот, никакой адаптации проводить не надо, потому что здесь, значит, риск очень мал. А к нулевому риску обычно никогда и никто не стремится, потому что если бы довести до нулевого риска, это было бы слишком дорогое удовольствие. И, наконец, если попадает в область желтую, вот здесь-то нужны экономические расчеты. И вот экономические расчеты, да, значит, так, сейчас, ой, не туда. Ну что такое? А что такое?
Назад,
Так я и тут, и тут.
Назад, да? Вот это?
Назад. Нет, дальше. Еще. Вот. Вот для того, чтобы выбрать способ адаптации и привести экономические расчеты, экономическое составляющее обязательно, необходимо сначала посмотреть, какие вообще существуют методы адаптации. Существует много различных классификаций методов адаптации и по пространству, и по времени, и административные. Но вот это классификация по функциональному признаку. Здесь адаптационные меры делятся на технические и на информационные. И выбраны нами потому, что именно гидрометеорологические меры являются в основном адаптационными, информационными. Так вот, тут перечислены эти все методы, но нам представляется, что одним из наиболее важных методов является обновление нормативных документов. Потому что, по сути дела, все обслуживание хозяйства, все обслуживание экономики происходит именно по нормативным документам. Используются те климатические показатели, которые есть в нормативных документах. Те, кто занимался обслуживанием экономики, те это очень хорошо знают, что в основном требования к нормативам. Сейчас в России и в странах СНГ происходит обновление этих нормативов и идентификация их с еврокодами, с европейскими кодами. Это вот очень важная задача, и ее нужно решать в первую очередь. Это задача и, так сказать, государственной системы адаптации, одна из наиболее важных. И это именно задача, которую должны решать климатологи. Потому что касается технических мероприятий, то технические мероприятия это не совсем наша область. И более того, потребители считают, что это их прерогатива, но на самом деле обязательно нужны соответствующие рекомендации, которые бы выдавались климатологами. Вот здесь экономические методы оценки рисков. Значит, тут целый ряд известных методов. Вот первый, второй, третий – это известные методы, которые чаще всего используются. Но нам кажется наиболее интересным метод, разработанный гидрометслужбой Великобритании. Его мы рекомендуем. Этот метод называется метод реальных опционов. Он отличается от трех предыдущих тем, что в нем меньше всего неопределенностей, а это достигается таким образом, что адаптационные меры с течением времени модифицируются. Например, стена, защищающая от наводнений, с течением времени меняется, ее конфигурация меняется, и тем самым достигается выгода определенная. Ну и потом наш метод собственный, который, значит, метод ГГО. Метод этот называется методом полной экономической оценки, и его преимущества состоят в том, что он позволяет вовлечь в процесс адаптации людей и органы, принимающих решения. Вот на третьей Всемирной конференции главы государств, то есть высокий сектор, все они предлагали поставлять им информацию, об этом сказал и господин Фролов, поставлять информацию не в обычном виде, в каком ее представляют климатологи, а в таком виде, которое подводило бы их к принятию решения. Так вот, этот метод позволяет привести к решению. Значит, что в этом методе хорошо? Он немножко громоздок в математическом смысле, но зато он очень полезен для людей, принимающих решения. Значит, прежде всего, экономико-климатические ресурсы определяются. Затем вот ряд методов расчета привлекательности инвестиций. Ну, это здесь три самых главных. NPV, вот это метод окупаемости, периода окупаемости, ИРР. Вот эти методы, они позволяют оценить, значит, насколько целесообразно делать инвестиции в то или иное адаптационное мероприятие. А затем необходим, вот это уже метод метод немножко более сложный. Здесь необходим ряд методов. Необходимо оценить, воспользоваться теорией решений, определить, насколько, значит, целесообразно тоже принимать то или иное решение по адаптации. Вот. Значит, это метод, например, минимаксный, это метод главного критерия, это еще целый ряд. Тут очень большое количество методов, но вот 3 выбраны, которые были изложены. Ну вот этими методами мы уже воспользовались неоднократно и давали их потребителю. Вот в данном случае, тут приведена карточка, был такой запрос от правительства, когда нужно было оценить, какую альтернативную энергетику надо развивать на Дальнем Востоке, потому что Дальний Восток наш попадает в зону риска так же, как и Япония. И там нельзя традиционную, нецелесообразно традиционную энергетику развивать, а нужно альтернативную. Но какую именно, в каких именно районах? Вот это с помощью вот этих методов, вот этой всей методики, о которой говорилось, вот решена была такая задача, где нужно развивать гелиоэнергетику, где ветроэнергетику, где гидроэнергетику, ну вот, так сказать, на строгой научной основе. И теперь в заключение следует рекомендовать вот следующие меры адаптации. Я их просто могу зачитать. Значит, ну вот видите, значит, здесь самое главное, что нам представляется целесообразным для России, также, мне кажется, и для развивающихся стран. Это создание атласа рисков, не отдельные карты рисков. Отдельных карт рисков вообще уже сейчас сделано очень много. Но вот должен быть такой атлас по стране, по каждой стране. Затем вот обновление нормативных документов, о чем я уже говорила. Ну вот, это самое главное, что нужно сделать. И, кроме того, в программу ГРОКа, которая сейчас вот как раз рассматривается, и есть уже первый ее вариант, необходимо поставить рекомендации вот по расчету адаптационных мероприятий, мне представляется. Потому что вот, мы обсуждали этот проект у нас, и наш представитель будет выступать в соответствующем месте. Нам кажется, что вот экономическая часть там немножечко упущена. И что вот, а ведь главная задача этого ГРОКа – это как раз обслуживание экономики. Так вот, в эту часть очень важно было бы включить рекомендации, где конкретно говорилось бы о тех мерах, которые можно использовать. Все. Все.
Thank you very much, Professor. This is mine.
Еще. Это не это ваш? Это его ссылка.
Это моя.
Нет, ссылка.
Thank you very much, Professor Madam Nina Kubisheva, for interesting and scientific presentation. And may I request Professor Isabel Niang, Sheikh Anta Diop University of Senegal, on title of Adaptation to Climate Change in Coastal Countries of West Africa. Madam, please.
Thank you. I will try to talk to you about one project that has been conducted in West Africa. But first I will like to recall why adaptation is needed in Africa and why adaptation is a priority. It's not only because the continent is more vulnerable, but also that we can't expect the results of the international negotiations to act now. And the fact that climate change, in fact, will strengthen the already bad situation existing in the different countries. So this project was a GEF project, GEF-funded project, It started in the end of 2008, and it will end by this year, by December. It is in the portfolio of Jeff. The main implementing agencies are UNDP and UNESCO as an executing agency. Actually, it has been reduced to 3 years, so it will end by December. The total budget was $13.18 million, but in fact, we mostly worked with the Jeff funding, which is $3.3 million for 3 years and for 5 countries, and including the regional coordination. These are the goals of the project. I will not insist on that. We focused on coastal erosion, and we tried to find ways to strengthen the responses of the ecosystems and communities to the impacts of climate change, and especially of coastal erosion. We have different components. So we are working at different levels, at local level, at site level in the countries, at national levels. These are the 2 first results that are expected, and also at regional level in order to strengthen regional cooperation to increase the combat against coastal erosion and to learn during this process. These are the sites that have been designed. You can see that for each country we are working in Mauritania, Senegal, Gambia, Guinea-Bissau, and Cape Verde. And each country decided to have 3 sites to work on, and it was during the PDFB. And we asked them to focus on 1 site. So you have here the sites that have been chosen by the different countries. Nouakchott in Mauritania, the Delta of Saloum in Senegal, the Alayan Delta and Bal Cape for Gambia, and Varela for Guinea-Bissau, and the Mayo Islands for Cape Verde. In Mauritania, the main work was to try to fill in the breaches in the littoral dunes, because there are sources of flooding of the Nouakchott area, which is the capital of Mauritania. So what was used was mainly mechanical stabilization of the dune, and then after biological fixation. But we had also a lot of work on sensitization, mainly with scholars and parliamentarians. And at national level, there was we tried to include climate change issues into national park management, and also in the main towns, the directorships of the main towns of Mauritania. And so in Senegal, we mainly did the work of mangrove restoration and dune afforestation. There was a lot of work on support to local livelihoods, because you can't expect people distract from them their activities to try to adapt to climate change. And we tried also to include climate change issues into the local development plan. And at national level, it was mainly the work on the littoral law. We also did some work on coastal erosion and the rates with the West. It was the UMA body which launched a regional project to combat coastal erosion. In Gambia, we mainly developed an ecotourism camp in one of the reserves of the Gambia, Coastal Reserve. But we also did some work on Sandwatch, which is a program supported by UNESCO, and it's about education at scholar level on coastal changes. In Cape Verde, there was a lot of sensitization, especially during the day of environment. but also a lot of work on, to support the campaign for turtle protection. And there was the site where they decided to intervene was a site where most of the agriculture was produced before the invasion of the place by seawater. So we tried to restore this zone in order for farmers to continue to grow their production. There was also a lot of integration of climate change issues into local development plans. These are photographs from the National Coordinator about reforestation. In Guinea-Bissau, the rate of erosion is quite important in the place, the site they decided to choose. So there was a lot of sensitization, beach cleaning, mangrove restoration, but also the combat to have a more efficient way to cook. And this was also, it is a photograph that was taken by one of the partners in Varela, who attended a meeting, a regional training meeting on Sandwatch, and tried to reproduce that in his own school. At regional level, what we did is mainly about capacity building. We did a lot of training workshops. We tried to develop the communication between the different countries through a website. We supported the regional cooperation through the building of one network of parliamentarians in the region, which was developed by the PRCM. We also pushed for Sandwatch training. And actually, this year we ended by the creation of a network of local stakeholders on adaptation in coastal zone. And we also preparing a guidebook for local decision makers on coastal adaptation options. In conclusion, a lot of expectations have been raised at local level. It is impossible to consider adaptation options without considering livelihoods in the sites. At national levels, you need to develop an adaptation strategy in order that what we do at the local level is not out of the national strategy and out of the regional strategy. And there is a need for better coordination between the different countries. So we are working actually for phase 2 of this project. Thank you very much.
Yes, please. Thank you very much. Thank you. Thank you very much, Madam Professor Isabel Nyang, for your interesting presentation. May I invite the next speaker, Mr. Sachidiananda Satapathy, Ministry of Environment and Forest, Government of India, on title Climate Change Assessment and Adaptation Policy in India. Please, you have to.
Thank you, co-chairs and my fellow delegates. First, I would like to extend our thanks on behalf of Government of India to the Government of Russian Federation and the organization of this workshop for inviting us to share the experience what we have gained during past few years and what we are attempting for future years. As this is known that climate change, it is a development challenge which is against our developmental activities and livelihood and poverty alleviation, and overall in order to meet the Millennium Development Goal. As we are guided by IPCC's report, as of now there are 4 reports, it was explained by IPCC chairman yesterday. AR4 confirms the anthropogenic activity as the cause of climate change in addition to the natural activities, and it emerges as a challenge for our development, more specifically for developing countries, and as a whole for human being. Impacts, the climate change impacts, it jeopardizes the input of development. Input of whatever we need for the developmental activities, these raw materials or the inputs are being affected by climate variabilities and its manifestations. And again, this is one of the IPCC presentation. Yesterday we saw it. And these are the variation what are likely to happen in future years in the event of rise of temperature 1 degree, 2 degree up to 6, and in different sectors like food, water, ecosystem, extreme weather events, and risk of abrupt and major irreversible changes. And so far we have heard a lot of things about the risk and abrupt and major irreversible challenge. And the IPCC is also releasing, soon after the approval by IPCC panel, a special report relating to risk and adaptation options. And I hope that will guide us for future adaptation policies at national and subnational level. As I mentioned, climate change and its variability and manifestations are a challenge to the development. And development and changes are integrally linked, as GHG emission is one of the driving force, and climate change affects all opportunities of development in different sectors, what we talked about in food security, energy security, and livelihood, poverty alleviation, all these. Then addressing climate change, it requires a shift of developmental pathway. Whatever developmental pathway we are following or we are preparing as a national strategy, that need to be revisited based on the climatic impacts of climates and other future projections made by through scientific researches. And the climate change can be addressed through a shift of low carbon growth, what we are talking at our national level, that following the low carbon path, we can achieve climate benefit in the terms of mitigation as well as the developmental path and in the various sectors. How we'll address climate change? In both way, in mitigation and adaptation. And by adopting these two methods, we can reduce the risk of climate change and the severity of vulnerability. And the mitigation, which reduce emission and promotes low carbon growth. Adaptation, which increases the resilience and reduce the adverse consequences and making us enabling to go ahead as per our future developmental paths. Climate change, again, it is a double challenge for policymakers, as at government level or at national government level. It is definitely severe challenge. How to address these issues? Government or federal government has different priorities, and according to priorities, development activities are envisaged. And in between, when scientific observation indicates there is vulnerability, we need to revisit the developmental activities and planning. And here, the challenge is how to adapt to climate change in various sectors, and most specifically in food security and energy security. Then how to make a transition to low carbon growth path. It is very difficult in developing countries to find out a transition from growth to low carbon growth. Growth means there is unconstrained growth where there is no limit for use of energy or use of carbon dioxide space in the atmosphere. But in order to have a low carbon growth, we need to squeeze our space and we need to develop our capacity to mitigate. At the same time, we need to develop our capacity to adapt to the climate extreme events. Here we have tried that it is just an established definition: adjustment in human and natural systems in response to actual or expected climate stimuli or their effects. It causes the global climate change in a mean global temperature and change in a regional temperature, which manifests or the impacts on rainfall and pressure circulation. And these are all the four manifestations interlinked, like how to mitigate the reduction of emission and how the greenhouse gas emission could be regulated and how to determine the climate change impacts and the action to mitigate or action to combat the challenges of climate change impacts, and the adaptation options to reduce vulnerability to climate change impact and to reduce the losses. This is the overall the adaptation planning what we need to develop at national level so as to meet the challenges of climate change at global as well as the impacts at regional level. Then while preparing the adaptation strategy, we are asking several questions that need to be answered for policy decision on adaptation. The adaptation option at national level, which is now acting as like an umbrella strategy. Each growth developmental activities need to be compatible to the adaptation strategy. Then what are all the changes going to happen to climate? That is to be determined based on the scientific information available at global level as well as national level. Then what will be the extent of and magnitude of climate change and its impact? Again, the information generated through scientific research, this could be determined. And the scientific information on future weather events and climate parameters significant for decision making on adaptation. As we are talking at a regional and global level, this is most important aspects to know the weather events or the climate projections. It is also important to understand the vulnerability associated with all sectors, all economic sectors as well as all developmental sectors. Then how to design an adaptation in the right paradigm and need for data. In order to develop a strategy, what we need, the challenge in policy making and formulating adaptation strategy is to know about the uncertainty in climate change projections. We are having several projections based on IPCC scenario, but again scientists feel that there are some uncertainties. And having these uncertainties, as a policy maker, we need to be very careful. Then integrating climate data into adaptation process. Here climate data mostly signifies the rainfall pattern, humidity, temperature and all these. And in the process of adaptation, because as we know that temperature, rainfall, it might have been influenced by climate change and it is also a natural process. As in case of India, if we analyze the last 100 years monsoon pattern, it is told that it is only a natural phenomenon. There is hardly any evidence to conclude that climate change is influencing the monsoon pattern in India. Similarly, the degree of uncertainty depends on the scale of analysis and climate variable of interest, including projections of temperature and much more certain than those of rainfall, as I explained, and the cyclone which is happening in Indian Oceans more frequently. Then design adaptation. The dominant paradigm to adaptation is two methods we are following. One is top-down, the scientific scenario approach based on impact assessment research undertaken in India as well as in the region. Then impact assessment research it is a complex challenge as it includes both physical, biological, and socio-economical aspects. As all these three aspects are focusing or all helping to the policymakers to prepare an adaptation strategy. And mostly the climate models as scientific information which gives us projections, and not exactly the prediction, but based on the projections, national strategy need to be reoriented. Then the bottom-up approach, it starts with an assessment of vulnerability at local level, regional level, as well as at national level. Then, based on the information of the vulnerability, either of a region or of a community or of a group of community, then it is to be informed, and with most specific reference to the livelihood of the people, because our main aim to eliminate poverty. Then, however, human experience is very subjective. It is attributing climate events to particular causes, including climate change, that only can be resolved based on the scientific information. Of course, there are a lot of uncertainties in the scientific information that need to be calibrated and confirmed, and based on the confirmed scientific information, the strategy could be developed at national level. Again, the scientific understanding from where we are getting the basic resources at present is the IPCC report. Then we have at our national level, as mandated by UNFCCC, India has prepared its initial national communication, which was submitted to UNFCCC. That covered the sectors like water resources, agriculture, forest, natural ecosystem, coastal zone, and health aspect. And these are the this is the map of India, where we have indicated different vulnerable area and mostly climatic extreme events like drought-prone, flood-prone, flood and drought in combination. And this is the peninsular region, which is mostly affected by cyclonic and heavy rain, and the central India, mostly it is drought-prone. Then, what actions we are taking at present to address these issues? That we have prepared a draft on low carbon strategy, which will be implemented from 12th five-year plan at national level. We have developed a national action plan on climate change, which comprises of 8 national missions and several other initiatives to address the need of the population as well as the government to address the climate change issues. Then, at the instance of our Prime Minister, all provincial governments have been requested to prepare their state action plan on climate change. Mostly it is an adaptation plan at provincial level to address the national issues as well as at regional level. Then a network system for scientific research and assessment, that is Indian Network of Climate Change Assessment, in short form INCA, has been launched in 2009 to undertake all scientific assessment with specific reference to India. Then we have a high-level expert committee to assess the impact of climate change in 6 thematic regions, like agriculture, water, then modeling, then coastal, then disaster and health aspects. Then preparation of national communication. We are preparing the second national communication and covering all aspects what we did in case of first, in addition to the new events, what we are foreseeing that in future India need to address. Then we have also a nationwide initiative on climate resilience agriculture. As I mentioned, in India, the food security is one of the important aspects to be addressed. We have initiated a national program on climate change resilient agriculture. Then we have a lot of bilateral and multilateral engagement in the field of climate change research. Then this is what I mentioned about the low carbon strategy for inclusive growth. This has been prepared as a draft by our planning commission, which is in circulation for comments of various stakeholders. And here we are mainly addressing the reduction of carbon emission, GHG emission in major sectors like power, transport, industry, building, and forestry. Once it is finalized, definitely it will be provide all supports to national government as well as provincial government to finalize its adaptation strategy. Then National Action Plan, what I mentioned, of course, the missions what we have, I will just explain. There are 8 missions. One is water mission. It is for sustaining Himalayan ecosystem. We have large Himalayan system. Then Green India means, again, we are talking here about forestation, sustainable agriculture to meet the demand of food security, sustainable habitat mission to conserve energy at commercial and domestic buildings. Then we have one important mission, the National Mission on Strategic Knowledge for Climate Change. Here we are trying to accumulate or to concentrate knowledge relating to climate change research. Here we are addressing all scientific all parameters relating to climate change, including modeling, then strengthening of observational network, then research infrastructure in India. Then, as I mentioned, all provincial government, they are also preparing a state action plan on climate change that it will enable the environment for implementing of NAPCC at state level, then to address the state-specific priority issues like as you see in case of India, we have different biogeographic region, and the issues are also different from region to region. And through state action plan, they need to address their individual issue with the support of national government. Then it will also provide a bottom-up approach to implementing climate change adaptation strategy. And it will provide the inclusion of community knowledge, experience along with scientific assessment of climate scenario and impact on various sectors. Then how it was developed, we don't have to discuss much. Then Indian Network on Climate Change Assessment. Under this program, we have 4 major programs at present. We have undertaken the assessment in 4 sectors in 4 regions of India. Then we have launched a black carbon program. Then we have initiated a program on long-term ecological observatory, and we are trying also to establish building capacity towards management of climate change and opportunities and at different regions of India. Then we have developed a greenhouse gas inventory by 2007. Then I mentioned what are all the programs we have initiated under this network. This 4x4 assessment, what I talked, 4 regions and 4 sectors. Then GHG inventory up to 2000, and our second national communication, it is covering again, it is an integrated approach, water, agriculture, food security and livelihood. Then water, agriculture, human health, then forest, then natural ecosystem and livelihood, energy system and infrastructure. It is giving more emphasis on livelihood and climate change adaptation. Then, as I mentioned, initiative on climate change resilience, it was launched in 2011, and it is covering almost all corner of the country. And here the main focus is 100 districts of India, which were identified as vulnerable. Then these are all detailed activities to be undertaken. Then multi-pronged awareness generation program is also included. Then strengthening of research infrastructure and capacity building. Then support for small and marginal farmers in rain-fed area and coastal and hill area. Then there are some ongoing programs on adaptation that I have given here from 2001 to 2007. Then these are the programs like how we have taken initiative for crop improvement, then drought proofing, then water conservation, coastal management, then health protection, then risk financing, and disaster management. Disaster management, at national level, we have one institute of National Institute of Disaster Management, and each province they have the state-owned institute to look out to address the disaster issues, because mostly in the coastal states are facing cyclone, and central states they are facing drought. In this way, disasters, these extreme events are more frequent throughout India. Then before concluding, I would like to say that we are also here to learn something and to share something, to have a better strategy to fulfill the objective, one of the objectives of Cancun Agreement, that is preparation of adaptation framework. And many thanks for hearing.
Thank you very much. Thank you very much, Dr. Satapathy, for your informative and comprehensive presentation. I may now invite last speaker for this morning session, Dr. Petteri Talas, Head of Finnish Meteorological Institute, Finland, on title of Adaptation to Climate Change in the European Arctic. Please, you have.
Good morning, everybody, and I'm going to bring you to a little bit different climate from the two previous speakers. So, in the Arctic, we are living in a little bit different conditions than in India or in West Africa, and this icebreaker here just demonstrates how we run our winter maritime transportation. I'm going to talk to you about what we know about climate change and what kind of changes we expect to see in the Arctic, and what it means for agriculture, forestry, and hydropower production, and so forth. And finally, I will touch what we have seen in the Arctic and what is expected in the Arctic in the future. First, some global pictures about changes that we have been observing. So you all know what's happening to the temperatures, and there are also issues happening in the middle atmosphere. So we know from the sounding observations that the whole troposphere is warming, but at the same time we have seen the stratosphere is cooling. I will come back to that later in my presentation. And then we know some other changes, what's happening to the snow and ice cover, and what's happening to the sea level and glaciers. And some of these issues are actual in the Arctic. For example, we are observing that the springtime snow cover in northern hemisphere is shrinking, and that's also the case with Arctic ice cover. I will come back to the Arctic ice cover a little bit later on. And we know what's happening to the emissions. Perhaps I don't have to tell you more about this. And we have also observed that the sea level rise is following the upper limit of previous IPCC predictions. And the global carbon dioxide emissions, they are also increasing more rapidly than before. There was a slight dip in 2009 because of the economic crisis, but in 2010 we were again up to this rapidly increasing curve that you can see during the past 10 years. And we are going to see the first results of the next IPCC runs in December, when the first review of the paper starts. And here we have two alternatives for the future. In the upper panel we have the 2-degree goal, which has been on the political agenda, but at the moment it's quite unrealistic that we would be able to reach that anymore. So more we are going towards this business as usual scenario, which means that we will see quite high temperature change numbers by the end of this century. And especially you can see that there are fairly high numbers in the Arctic area. Another thing that we are concerned of is are the changes in precipitation. This is an old graph just demonstrating that in most parts of the world we expect to see more drought, but at the high latitudes we expect to see more rainfall, and that has an impact on our future climate in that part of the world. Sea level rise, most likely we will see in our next IPCC report an update which suggests higher sea level rise estimates than in the previous report, and we will hear about that very soon. And about the impacts worldwide, we are very much concerned what's going to happen to the food production capability of our world, and here is a sketch produced by UK Met Office in which part of the world we expect to see decrease in our cereal and livestock production, and in which parts of the world we expect to see an increase. Mostly the forest growth will be better in this new world, but there will be less capacity for food production. And again, if you look at the high latitudes in the northern hemisphere, you can see that the colors are usually blue. That means that we expect to see an increase in that part of the world. But the capacity of that part of the world to produce food for the rest of the world, it's very limited. So we cannot complement what's going to be missing in the rest of the world. And what we have observed in temperature so far, this is a temperature record for the past 60 years. And again, you can see that the Arctic has been warming up the most in the world. And here you have a record for the past 150 years. Here's an individual country, Finland, and in the lower panel you can see the global average. We can see the same features in the global average as we have seen in Finland, but the year-to-year variability it's much higher. So it varies several years from several degrees from year to year. And the ordinary people usually believe in climate change or not believe in climate change because what they observe. And since we have this variability, it's sometimes quite difficult to convince the local ordinary people that there's a thing called climate change. There was this famous heat wave hitting especially Russia, but also Finland in summer 2010, and we broke all the records in Finland, and also in Russia the records were broken. In our case, the single temperature record was 37.2 degrees, and our July average was more than 24 degrees, which is a very high number to this kind of northern country. And it has been a debate whether this is because of climate change or something else. It's not because of climate change, but statistically we already see more often such events to take place. In the past climate we observed them every 300 years, and in the present climate every 60 years, and by 2050 we expect to see them every 10 to 15 years. And there were plenty of deaths, both on Russian side and Finnish side, but they were partly because of the forest fires and peat fires here in Russia. And if you look at this period from global perspective, this is European Centre May-July temperature mean for the whole world. You can see that this was an unusual period, and we have seen more such warm temperatures during the past 10 years than before. It's always important to have a look at the global perspective when you talk about regional or local temperature anomalies. This is the August for 2010, and you can clearly see this Russian heat wave, but you can see that also on the Pacific we had colder temperatures than the average. And after that we faced very cold winter in Europe and also eastern part of United States. And here is January 2010, And then people say that, okay, there's no climate change. It's very cold and climate change is over. And that's a big challenge for us meteorologists to tell what's really happening. And again, here you can see that the global average was above the normal in January 2010, but in certain areas we had cold temperatures. And how often we expect to see such cold winters in the future? In the past, we used to see them every 6 to 8 years. In 2010, every 13 years, and by 2050, once every 100 years. So that's what we expect to see. So in the warmer climate, so this distribution of the temperature is going to change. We have also seen change in the snow melting date in Eurasian region. This in the upper panel we have satellite observations, and the lower panel we have ECAM climate model runs for us. And today this snow is melting already 1 week earlier than 30 years ago. So there has been a change already now. And now I will come to the North European region, what we expect to see in temperature first. And in temperature-wise, here we have the normal period 71 to 2000, and in the right panel we see what's going to happen by the end of this century. And the climatic zones are going to move about 1,000 to 1,500 kilometers northwards. So what we today have as a climate in Germany, that's going to be the case in Helsinki by the end of this century. And likewise, what we observe in southern Scandinavia today, that's going to be happening in northern Scandinavia by the end of this century. And some examples what's going to happen for some parameters. For example, the forest fire risk days. Since because of the warmer summers and more evaporation, we expect to see a doubling of the forest fire risk days. And there will be a change in the days with the snow cover in southern Scandinavia. The change is close to 70%. And in northern part, in Lapland, close to 20% decrease in the days with snow cover. And some studies from Finland. Forestry is very important for the Scandinavian countries and also for certain parts of Russia. And at the moment, the further southwest you go, the better the forests are growing. And in this changing climate with more precipitation and higher temperatures, we expect to see better forest growth, and especially in eastern and northern part of Finland, we expect to see much better forest growth because of climate change. And also our growing season is going to be longer. Here we have a graph showing how many days the growing season will be longer because of climate change. And again, it's temperature and precipitation are the factors behind. We are not going to change the solar angle, so that's going to remain the same. In southwestern part of Finland, we expect to see up to 2 months longer growing season, and some people are even dreaming of growing wine in that part of the country. And in the rest of the country, it's a little bit more than 1 month longer growing season. We also expect to see increase in the hydropower potential because of the increased rain amounts. And this black curve shows what is the situation now, how we get hydropower. So we have a peak in spring when the snow and ice are melting. And in the future we expect to see also more floating water in the system in autumn time and winter time, altogether about 20% increase in the hydropower potential. Sea level rise in the Baltic Sea, it's different from the oceans because we still have the land is still rising because of the last glaciation, and that's why we expect, for example, on the west coast of Finland, still a decrease in the sea level, and in south coast we expect to see a slight increase in the sea level. And then I would like to touch the issue of disasters. Here is what we have seen globally in the amounts of disasters. And you can see that there has been an increase in the meteorological disasters that are related to the weather and water issues. And we also know what kind of damage these disasters are causing and what are the costs of these disasters. And the area where the costs are the highest is Asia, and second is Americas, and third Europe. And the absolute costs in Oceania and Africa are fairly small. That's because of the size of the economies. And in Europe, we are mainly dealing with flooding and storms when it comes to disasters. and this heat wave that we observed in July-August 2010, we also observed the most severe storms, small-scale storms that were coming from southeast. And usually in Finland we issue general storm warning every second year. And this summer, July-August 2010, we issued 10 storm warnings in 2 weeks, and that was really unusual. And the question is how much we expect to see such events in the future because of climate change, and we know that we already have more humidity in lower atmosphere, and the potential from that perspective is higher. Okay, and finally I would like to touch the Arctic issues. So Arctic is a very interesting area, and the political interest towards Arctic is highly growing at the moment. And there are new countries that would like to become players in the Arctic. For example, China is actively seeking for membership in the Arctic organizations. And today we already have some minerals there. We have tourism to very limited degree. We have fisheries, and we have oil and gas exploration activities, and also summer sea lift activities. And you have seen that the Arctic sea ice is melting, and this year we broke the record in the extent of sea ice, and we all know that this melting has taken place faster than expected in the 2007 IPCC report. And what is also special now is that we have very little multi-year ice in the Arctic. In the past, the majority of the ice used to be multi-year ice, but today it's only a very small fraction. So we have a minimum of the multi-year ice in the Arctic today. And here is what the situation has been. This year we have seen this northeastern passage has been open for a couple of months, and there has been also some opening in the northwestern passage, and that's expected to continue. In 2007, when we had our previous record, we had also a little bit special wind conditions that was causing this minimum, but this year the wind conditions have been so-called normal, and it's very much because of the melting that we have seen this lower amount of sea ice. And of course the interest is whether we could start using that part of the world for commercial fleets, and the attraction is that the sea route through this northeastern passage would be 40% shorter than the southern one, if you go from Hamburg to Shanghai, for example. But there are some limitations. We are still going to have winter in the region, so this shipping is not possible without icebreakers in winter time. And the routes are not as steep as the southern route, so you have to use small ships. And then we have a lack of safety infrastructure. We don't have proper weather or marine services for the region, and then it's Russian territory that we have to pass there, and so far it seems that the costs will be fairly high for this transportation. then it's important that developed country Met services are assisting less developed Met services in the world, and Finland is one of the countries that is doing such work. Then we are having also scientific collaboration with several countries, and we have just established a new station to Siberia together with USA and Roshydromet. It was opened last year, and there we are monitoring what's happening to the Arctic greenhouse gases and aerosols, and this is an ideal place for such measurements, and we have been observing fairly high concentrations of methane, and it's likely coming from the ocean areas, not from the melting permafrost, which was the previous hypothesis, and scientists are now preparing a paper to Nature about those findings, so it's very interesting. And I would like to thank Roshydromet for this excellent collaboration, and especially Vladimir Katsov has played an important role to get everything up and running there in Tiksi. Okay, and my final slide about Arctic is that I already showed that this Arctic stratosphere is cooling in the Arctic. That means that we are facing more Antarctic type of meteorological conditions in the Arctic because of that, and last spring we observed the most severe ozone depletion in the Arctic so far, and there's a risk for seeing more such events in the coming 20 years because of this cooling of the stratosphere. Okay, my conclusions. Climate change, although it has some positive impacts regionally, it's a risk for the well-being of mankind globally, and especially the capability to produce enough food. That's a matter of concern. At the moment, we haven't been able to reduce the emissions of the greenhouse gases. There have been some limitations in Europe, but that from global perspective, that's still peanuts, and this 2-degree target is not realistic. And there should be much more emphasis on adaptation, since this mitigation seems to be failing. And there's also it's very important that we also build disaster risk reduction systems, and especially pay attention to the ability of the Met services to provide early warnings of disasters, and that's very profitable way of adapting to climate change. And regionally, we can see also opportunities, and for the Arctic, it's important that we start building capability for observing the weather and the marine conditions, and build similar weather and marine service infrastructure that we have in the rest of the world. And there's an urgent need for satellite observing systems for the Arctic, and also telecommunication systems for the Arctic. And finally, I would like to introduce you the most recent observing instrument that we have invented in Finland, and Finland is producing meteorological instruments, and if you want to buy one of these instruments, please consult me after this presentation. Thank you.
Thank you very much. Thanks. Thank you very much, Dr. Talas, for your comprehensive presentation and information about European Arctic activities on the matter of adaptation to climate change. We have finished duties to our session this morning, and we will present summary and result of our speech tomorrow to the plenary. May I request my dear co-chair to give us some remarks and comments, please.
Спасибо. Ну, во-первых, я хотел сказать, что у нас
прошла довольно удачно, на мой взгляд, эта сессия. У нас достаточно широко были представлены и разные регионы мира, и, значит, разные, так сказать, стороны диалога в процессе адаптации, и люди, которые работают в правительстве, и люди, которые занимаются наукой. И мне кажется, что это такой интересный обмен, который, кстати, между прочим, может быть продолжен во время постерной сессии, поскольку у нас довольно-таки много докладов поступило по этой части вот в качестве постеров. Мы, конечно, немножко еще поработаем с господином Нуряном, с доктором Нуряном, и, значит, поможем завтра нашему, значит, председателю сделать некое заключение по поводу всего того, что делалось на этой конференции, что обсуждалось. Это потребует некоторой работы, конечно. Тем не менее, я хочу сказать, что удачно получилось и то, что у нас все докладчики, которые, так сказать, предполагались, они у нас выступили. И я очень благодарю всех докладчиков, но я хочу также еще и поблагодарить вот кого. Мы понимаем, что бывают разные обстоятельства, и иногда кто-то не приезжает, и, так сказать, бывают всякие накладки при подготовке, значит, вот, секций. Поэтому у нас были докладчики, которые могли в любой момент выступить, если бы кто-то из сегодня выступавших не приехал. Я хочу особенно поблагодарить моих коллег, двух ведущих ученых Росгидромета, профессора Олега Сиротенко и профессора Олега Анисимова, которые были готовы в любой момент, значит, сделать презентации. Вот, но одновременно они сделали свои постерные тоже доклады, поэтому я, пользуясь, так сказать, вот своим служебным положением, административным, очень рекомендую вам пообщаться с ними во время постерной сессии. И я думаю, что на этом мы, может быть, даже на 5 минут раньше можем закончить нашу секцию. Большое всем спасибо, и докладчикам в особенности.